CES is the mecca of consumer electronics. It's always a lot of fun to be here. We've got a lot to tell you today, and so let's get started. To say that consumer electronics has been transformed, revolutionized in every possible way over the last 10 years can't possibly be overstated. So much has changed. You could say that it all started with the iPod. With our music on our PC organized by iTunes, iPod made it possible for us to take it everywhere. Their catchphrase, 1,000 songs in your pocket, made it possible for us to enjoy music anywhere we wanted to be. Then several years later, Amazon introduced the Kindle and made it possible for you to enjoy books in a really convenient way. Download a book in just 60 seconds without even being connected to the PC. All of it untethered, just from the cloud. Several years after that, the cloud became even more powerful and started streaming video to your television. Soon clients cropped up. You could stream video and television and movies, all the way to phones, tablets, and anything with a smart application processor inside. And today, your mobile devices can also stream. Phones can stream to wireless jam boxes, and your iPad could stream the movie you just made on a vacation to the AirPlay, over the AirPlay protocol, to the Apple TV connected to your television. So now all of a sudden, within just the course of 10 years, everything has changed. Your digital device could enjoy music, movies, books, connected to PCs, unconnected to anything, enjoyed it right from the cloud, and also to enjoy it on any device, any screen, television, phones, PCs, otherwise. Everything has changed. Now the ironic part of it is that all of this has changed, and it didn't include the single largest entertainment industry. Whereas music and movies and books are now enjoyed in this wonderful new way, video games, the largest industry of all today, can't benefit from this style of entertainment, untethered. It isn't possible for you to enjoy your video game on any device. The same video game on any device. It isn't possible for you to be untethered. And so the question is, what is it that we have to do as an industry, and what technologies have to be invented to make that possible? And so today, over the course of the next 90 minutes, we'd like to talk to you about some inventions, some new products, some new ideas we have to make this giant step forward in how we enjoy video games. But let's start with PCs. PC gaming is thriving. PC gaming is thriving. These games are huge blockbusters. When I said earlier that video games is now the largest industry, the blockbusters are also the largest events when they come out. Call of Duty Black Ops 2 was introduced to a blockbuster, 24 hours, $500 million. No movies in history, no entertainment media in history has ever rivaled that introduction. 2 weeks later, Black Ops 2 did $1 billion. One single genre of video games, MMOs, massive multiplayer online games, does $13 billion a year in revenues. To put that in perspective, NFL does $9 billion. That's one single genre. To say that video games is a massive entertainment industry is really an understatement indeed. And yet, on PCs, you see innovation happening faster than just on any other platform, because fundamentally it's open. It's innovating constantly. Anybody can participate in it. Any video game developer could create games for it. And as a result, new ideas are fostered. Free-to-play games now represent the fastest growing sector. League of Legends is a phenomenon like no others. Not only are free-to-play games and game developers innovating, the gamers themselves are innovating. The gamers are publishing themselves. The gamers are creating their own software, creating their own content in these free-to-play environments, and selling the digital goods. You hear stories, somebody in a video game creating a hat or creating hats and selling it over the course of a year, generating $100,000 a year. So all kinds of great innovations from game developers to gamers and the industry itself. As wonderful as the PC industry is, though, it is awfully chaotic as well. It is really one of its beauties. Whereas the game console is always stable, one single configuration, the installed base, all one common configuration. In the case of an Xbox, for example, 3 cores and GPU of about 240 gigaflops. The PC industry has a range of personal computer configurations based on your price, based on when you bought it. Just to give you an example, a high-end PC game today, or high-end PC today, has a Core i7 with 6 cores, and a GTX 680 with 3,250 gigaflops. 15 times more powerful than a game console. And it has to range all the way down to an integrated graphics PC with 2 cores and 125 gigaflops, or about half the performance of a game console. And the installed base has configurations that have shipped over the course of the last several years, and as a result, you have hundreds, thousands of different configurations that have to be accounted for. Well, the game developers came up with a great idea. It's called game settings. Now, these game settings allows you to configure the game so that you can reach the full potential of your PC. With different settings of resolution, texture fidelity, the environment settings, the draw distance, the amount of trees, the amount of particles, even great things like anisotropic filtering, because we know that 3D graphics filters and textures are in 3D space, very different than a video and photograph, which is in 2D space. The filtering technology has to be different. The way that the lighting is done, companies like ourselves create technologies like screen space ambient occlusion, SSAO. All of these technologies are so confusing. How is it possible that a game player could possibly understand these different technologies and how it impacts the game? And how could they possibly, with all these different configurations and all these different PC hardware that they have, how could they possibly find the best settings? Well, it turns out that about 7 years ago, we had just created this new GPU called G80. Does anybody know the G80 code name? Okay, so it's Geforce 8800. The Geforce 8800, I was so proud of it. I took the first one home, I took it home to my son Spencer, and I said, hey, install this new graphics card, you're gonna love it. And so while he was installing it, I went out of the room, I came back a few minutes later, and I said, okay, well, how's it look? And he's already playing. I think he was playing Call of Duty, he was already playing. And I said, well, did you change the settings? I mean, I want to see it amped up. And he goes, Dad, I just want to play the game. I just want to play the game. And why can't you guys just set it for us? Now, I told him 7 years ago, I said, son, this is technical. That's why they pay us the big bucks. There's a lot of technology in here. How do you just set it automatically? It's not possible to. Well, quietly, I knew that he was right. The fact of the matter is, it's very unlikely for all the game players to figure out all the vast number of configurations. And so we went off and undertook an enormous project. We went off and we tried to characterize every single configuration of PCs out in the world, understood every single setting in every single game, and through heuristics, simulation, and very, very expert detailed game playing, came up with a technology that makes it possible for you to set the games automatically inside your PC. We had to create the algorithms necessary, the methodology necessary to do this, create a server farm, connected it to a cloud database, to a client that we developed. that you can install on your PC so that this can be done automatically. So 7 years later, ladies and gentlemen, and Spencer, on behalf of all the engineers at Nvidia, the hundreds of man-years of work that has gone into it, the inventions, the breakthroughs, we'd like to introduce you to Geforce Experience. Now, Geforce Experience, let me tell you about Geforce Experience. Well, the way that it basically works is we start by understanding the profile of every single game. We understand the settings. We know through heuristics, through simulation results, and through benchmarking, the performance characteristics of every CPU, GPU resolution combination of PCs in the world. By studying the install base, we can figure out which one to prioritize for. And then we use our expert gamers to literally play through these games to figure out what the settings are, update them into a cloud database, and before you need those optimal playable settings, and before you need those optimal drivers, optimized drivers, this client would alert you and let you know to install it. And you can opt in to install all this. When you launch the game, GFE magically inserts the settings into your game so that it comes up in the most beautiful and the most playable settings that your PC allows. And so as a result of that, she who buys the best PC gets to enjoy a game in its most wonderful possible way. Now to show you, why don't we play we're going to show you now an example of one of the games. This is the latest Call of Duty, and this is a video of before we did the setting change and after we did the setting change. Okay, so first, let's play the video, please. This is a standard out-of-the-box settings. This is standard out-of-the-box settings. Call of Duty, you download Call of Duty from Steam, and you launch this game on a Geforce GTX 680. This is out of the box. This is exactly the way it looks, and it's a wonderful game. Incredibly fun to play. If you're playing the game console, it looks approximately like this. It comes up in resolution of 720p, and it's incredibly playable. Wonderful playable. However, if you had GFE installed, and GFE comes now bundled with our drivers, if you had GFE installed and you simply clicked Optimize, this is what you see. Let's show you one more time, before GFE optimization and after GFE optimization. You see the slider bar? Before GFE and after GFE. The textures are much, much higher resolution. The rendering is higher resolution. You can see the watch. It's actually a watch. And if you go all the way to the left, there's two soldiers there. And now you can see them crystal clearly. So that's it, the benefit of GFE. The first thing we would like to do is create this client connected to the cloud that makes it possible for everybody's PC gaming experience to be as optimal as it can possibly be. And therefore, as a result of that, give you the simplicity of a game console, but the performance, scalability, and the performance of a PC. Something that has never been done before. We're incredibly proud of it. Now let's talk about something else. The cloud. Cloud computing has obviously changed everything. Its impact on the computing industry, the disruptions to the industry, the disruptions to the companies, can't possibly be overstated. It's all made possible because somebody figured out that instead of single applications running on each, installed and running on each and every one of our computers, a single installation of software in the cloud over the web, serving every user as a service, would revolutionize computing. That same service is now possible as a result of being located in the cloud to run on phones and tablets and PCs with different operating systems, computing devices of all kinds. I could probably guess that it went back all the way back to Hotmail, was my first exposure to a cloud computing applications. But since then, applications after another have really changed the way we use computers. To make it possible, something critical has to happen. The infrastructure cost of delivering that service has to be incredibly low. And over time, as the infrastructure costs of data centers continue to decline as a result of Moore's Law, the result of multi-core CPUs, the result of virtualization technologies, it has made it possible for us to deliver these services much, much more cost effectively. And as bandwidth and broadband continues to pervade the world, and we are now able to access broadband literally in everybody's home, and pretty soon in everybody's mobile device, the accessibility of cloud computing becomes greater than ever. There's no question at this point this is the best way of using computers. Oftentimes you buy a new computer these days and there's just no reason to install any software anymore because all of the software that you use are off in the cloud. Now the question is, why is it that this cloud computing architecture has benefited applications, has benefited maps, has benefited videos and music and books? Why is it that this technology and this incredible revolution in computing has left video games behind? Well, the fundamental reason is because video games is a unique medium of its kind. For those of you who use 3D graphics, play games, you understand this very much. Each and every single frame of a 3D graphics application was computed right then. Unlike a pre-recorded movie, where the movie is stored off on disk, and when somebody wants to play Iron Man 2 on Netflix, that disk file is being accessed and simply passed along in H.264 format to the end user, where it's decoded lightly using a video decoder. 3D graphics, on the other hand, the application, the textures, the objects, the world is being completely synthesized every time you touch that computer. Every single frame is being recomputed. The lighting, the character animation, the physics within it, the gameplay, the AI. How should the fighter respond to your moves, are all being computed in real time for every single frame. And so 3D graphics is in fact a rather unique visual medium, and its benefits are very clear. It allows you to be suspended in disbelief, allows you to enjoy an application in a different way every single time. And so the question is, what problems do we have to solve? There are 4 things we have to solve. We have to figure out how to make it possible for our GPU to render not to a display connected to HDMI or DVI, but to render directly out into the cloud. To render it in a remote way, in a very low latency way. That's the first thing we had to do. The second thing we had to do was to create a server system, because these data centers are racks and racks of servers, and these servers are used for general purpose computing. Lots of CPU cores and no GPU cores at all. We had to create a system that was dedicated and optimized for high density video game streaming. So this one server has to be dedicated really to computer graphics, optimized for computer graphics, to deliver the performance and to deliver it in a very efficient and very high density way. We also had to create a software stack. No software stack exists today that allows a singular computer to support and to connect to hundreds, thousands, millions of users and make it possible for each and every one of them to have a unique experience. And then lastly, we had to create a piece of software that sits in every type of computer as a client, as a receiver, that allows us to receive the streamed data in a very low latency, very high performance way. These 4 pieces of technology literally took us 5 years to create. Took us 5 years to create. And I'm incredibly delighted today to introduce you to Nvidia's first fully integrated product. A fully integrated system product. The Nvidia Grid. What you're looking at is the Nvidia Grid. Each one of these servers are designed and optimized for computer graphics. And within each one of these servers are packed full of GPUs. Just packed full of GPUs. And all of these GPUs are able to run concurrently, supporting many concurrent users at one time. Initially, we'll be able to support something along the lines of 24 concurrent users on one computing node. The way to think about that is, today, your PC supports 1. And so we'll be able to support 24 times more concurrent users right off the bat with a computer that occupies about the same amount of space as a desktop computer. So this is the Nvidia Grid. Well, let's compare it to a few things. So this particular rack has about 20 grid servers in it. It's packed with about 240 Nvidia GPUs, which gives you an aggregate 200 teraflops of GPU computational performance, which translates to about 720 Xbox 360s. Now, just to put it in perspective, 720 Xbox 360s is 10 racks. It would occupy the volume of about 10 of these racks, basically going all the way down the stage. It would consume about 5 times as much power as this one. Not to mention all the software that makes it possible for us to provide the connection broker with the end user that comes to enjoy the game. All of the load balancing and quality of service provisioning, and promising that that quality of service is now delivered on this particular piece of software. It is a virtualized piece of software, essentially a hypervisor that supports both CPUs and GPUs. Why don't we see what it can do? And so let's introduce Andrew Fear. Come on up here, Andrew. Andrew is going to product manager for Nvidia Grid. Now, what we're looking at here is a smart television. This is a smart television from LG, and the only thing that's connected to it, just so you know, we should take one of those rings. There's nothing connected to this except for Ethernet. Okay, the backside of this is simply Ethernet. Ethernet goes into a router. The router goes into an Nvidia Grid. That UI that you saw just a second ago, the Grid UI, that entire layer of middleware, that UI was rendered in the cloud. That UI wasn't rendered here. As a result, you could imagine whatever UI, whether TV is this model or that model, so long as it has an Ethernet jack and an application processor, that UI could be exactly consistent. You don't have to port the UI and the client for every single one of the televisions out there. Andrew, what are you playing here?
So I'm playing a game called Trine. It's a pretty fun game. I've been playing it for a while now. I'm a big fan of the series. And what I like about the game is, when you tell people, what do you do in the game? Well, you're a builder, you're a thief, you're a mage. I like to think of it as, I'm a guy with a sword, I'm a girl with a grappling hook, I'm a guy with a magic wand.
And you're all that at the same time.
You're not all that at the same time. The Trine is this magical object that lets you sort of change characters as you go. So when you're trying to solve puzzles and save the world, You can change a different character. You have different things. You can see here's my girl now running around with her grappling hook. And it's kind of fun. It's a beautiful world. It's completely rendered. The graphics are beautiful and smooth. And again, this is something just amazing for me to see this rendered all locally right here.
That's amazing. And so we're looking at a television that's, this is the latest smart television from LG.
That's correct.
And all we've done is we've taken the Grid receiver client, and they've ported that Grid receiver client to their television, and as a result, once you plug in Ethernet, you can stream the video game that's processing on one of these GPUs on a Grid server.
Now, absolutely. Now, what I love about it is that you get access to all these games instantly on a TV, but I'm sure like me, you travel a lot, right? You can't take your games with you all the time. You have saved games like I'm doing now. I'm saving this game. And one of the things that I like to do is, after I'm done playing my game, if I go on the road like CES, I don't have access to these games.
Now this is cloud computing.
Well, it is cloud computing. The thing that I like
cloud computing. So what could you do with cloud computing?
Well, the thing I like about cloud computing is that if I bring a device with me like my ASUS Transformer Prime, I can easily launch the Grid application.
Now go back. I think that they didn't change the view fast enough. Go back to, so this is a Transformer. This is now an Android tablet, and there's a little client on there called Nvidia Grid.
That's correct.
Right? Now this could be the Transformer Prime. This could be the Nexus 7. It could be a Galaxy Tab. It could be HTC One X. It could be frankly it could be an Xbox. It could be anything. Right? It has anything with enough, and it doesn't have to be very much. I mean,
it's just encoding video at the end of the day, right? So you can do lots of different devices.
So you launch this little client, and magically, amazingly, exact same UI shows up. This is the same UI that we showed.
All the games that I had over there, I have over there. And I think what makes it really amazing, as I said, is if I go on the road and I always try to, I want to do the right thing and I try not to get into trouble on the road. If you want to play games, it's a great secret. Don't get into trouble, you play games on the road then. And you can see here where I was in the game. I'll just go ahead and I'm going to go to single player and I'm going to load that save game I had just a second ago. And you'll see that I'll pick up playing exactly where I was on the television.
No way. All right.
I'm a big fan of this guy. I'm a pretty simple guy when it comes to things, and I like boulders and rocks and flaming swords.
So this is fantastic. So first of all, you're getting a graphics experience. You're getting a 3D gaming experience that isn't possible on even the Transformer Prime today. But the fact that you have the game in the cloud, you can get all the same benefits that you would have had with Kindle books or any of your cloud applications.
Just
wherever
like
you left off, you pick up.
Absolutely. Like you can pick up your videos, watch them anywhere you want, pick up your games, play them wherever you want on any device.
Oh, that's terrific. All right, congratulations. Thank you. So the Nvidia Grid is our first fully integrated system product. And we sell it to MSOs and to partners who are serving MSOs and anybody who would like to host and would like to stream cloud games. Today, we would like to announce some of our early partners for Nvidia Grid. These are really innovative companies from all over the world. Agawi is here in the United States. They're working with Microsoft, and they've been working on streaming Windows 8. You have G-Cluster, which is based in Japan, and they're working with SFR, and they're working with Orange. You have Playcast based in Israel, Ubitus from Korea, and they're doing trials right now with Docomo and Verizon. And you have CyberCloud and Cloud Union doing trials in China with some of their telcos. As you can see, cloud gaming is an industry that is about to come to fruition. The enabling technology, Nvidia Grid, has taken us several years to create, and finally it's been put together in a way that can allow these companies, our partners, to deploy cloud gaming globally and in a very, very large way. And so I want to thank all of our partners for joining us with Nvidia Grid, and I look forward to seeing the successful trials with these large telcos, and the many more that will be coming. I also want to thank all of the engineers that have worked night and day. You know, these projects, this particular project is our first fully integrated system. We had to architect a brand new GPU. We had to architect a brand new system from the ground up dedicated to this application. All of the system software that makes it possible to provision this quality of service and this complexity of service over the cloud, and also all of the client software that's out there. All of these are first of its kind inventions, and it's taken us 5 years to make it possible. I'm incredibly proud of the engineers that have made it possible, and let's give those guys a round of applause. All of you came today thinking you're going to hear a particular announcement. Several years ago, we started this endeavor to create single-chip mobile application processors. And the reason why we did that was because we felt that the future of computing would come in all kinds of varieties. The PC will still be amazing computers. As we just mentioned, the cloud will become a very important computer. Your data center is going to play a greater and greater role in how you and I enjoy our daily computing experience. But we also felt that everything will very likely become a connected computer. Your cell phone, obvious. Tablet, it is obvious now. But your car will become a computer. As you see, the LG television is a computer. All of these devices needs to be powered by sophisticated, low-power mobile processors. And so we started the effort several years ago, and we introduced, and we thought that performance was really important. That these operating systems need performance, that resolution requires performance, and so we took the lead in building faster and faster mobile processors. We introduced Tegra 2 at the time. People thought we were kind of crazy. Why would you need a dual-core processor for a mobile processor? And if that wasn't crazy enough, why don't we make Tegra 3, the world's first quad-core? And each generation, we took a performance leadership position. Well, ladies and gentlemen, today, to probably great surprise to all of you, I'd like to introduce the Tegra 4. Tegra 4 is nearly the worst kept secret. And the reason for that is because we had to start talking to our customers about it. The enthusiasm came so great around its introduction that specs of Tegra 4 floated everywhere. And we immediately received quite a bit of questions. The first question is, how much performance does a cell phone need? I'm reading books fine, I'm listening to music fine, my UI is just fine. I'm reading magazines fine. Everything works. Movies work. Everything seems to work. How much performance does anybody need in these mobile devices? Well, if you ask us, we need a lot more performance. We just need a lot more performance. And here today, I'm here to prove it to you. I'm here to prove to you that we need a lot more performance. Tegra 4 has 72 GPU cores. This thing is flooded with GPU cores. I just wish we could flood even more GPU cores in here. The second thing is, it is the world's first quad-core A15. Quad-core A15, which is ARM's new CPU architecture, and quite a bit faster than our last generation. We still have our power-saving core, this low-power core that hums along, sips little bits of power when you're mostly doing low computing requirement work, while you're reading a blog or just browsing a website or something like that. And then, of course, every mobile processor in the future will have to be connected, and 4G is obviously the next step. It includes a 4G, Nvidia's first 4G LTE modem. Now, the first question I like to answer is how fast does fast have to be? How fast does fast have to be? And why is it that we're not fast enough? And so, to show you, I would like to bring out the fastest tablet, Android tablet in the world today, and let's put it to a foot race on doing something that is very everyday. So what I'm going to do is I'm going to show you two tablets, one Nexus 10, the Samsung Nexus 10, and the second one with Tegra 4, and they're going to go through and load 25 web pages. 25 web pages. And I don't know how many of you are out there that wish loading web pages were just snappier. But I just all day long wish I could load web pages snappier. And so let's put the two of them to a foot race and see how they do. Now both of these guys are so that we could eliminate any uncertainty that comes along with the internet. We have the web pages fully loaded, and both of them are pulling it off of a server across over a router. So it's effectively like a controlled internet experience. So can you show us now, please? And so this is on the left is the Nexus 10, and we're going through websites here, Amazon's website, CNN, New York Times, and on the right is Tegra 4. And we're cranking along. And these are web pages that you see that everybody uses on a daily basis. And if it's not clear already, the Tegra 4 is doing quite well. And so it took about 27 seconds to load 25 unique web pages. And the Nexus 10, let's give it a chance here. Okay, there you go. We're just delighted they finished it. So that gives you an example, a real-world example of an application that we do all the time. Now, of course, all this basically means is this. If you're loading a website with Tegra 4, it comes up in a second, basically like that. If you're loading a web page with the fastest Android tablet in the world today, highest end Android tablet, Nexus 10, it would take 2 seconds. Now, frankly, I think 1 second is well, it's twice as fast as 2 seconds. And if I'm going through web page after web page after web page, 2 seconds really is something that I would like to improve. There's so many other tablets we can compare to, and I won't torture us with all of those. But Tegra 4 is the fastest application processor, fastest mobile processor in the world today. And if you can compare it to iPad 4, which is an incredibly fast CPU, it also has the benefit that every web page in the world is becoming optimized for the tablet. And even then, we're able to beat the iPad. Nexus 10 is the next fastest one, and then the Qualcomm 8064 Droid DNA behind that, and then Kindle behind that. And so relative to a high-end HD tablet today, Tegra 4 is somewhere between an Android tablet about 2 times faster to about 3.5 times faster. Now the question is well, gosh, that's one application. It's a very large application, no doubt, but it's one application. One of the things that I've always loved, and I wish we were to create this technology for our summer vacation. Over the holidays, for our kids' graduation, we took Spencer and Madison to Europe, and my job was to take pictures of the kids and to document all of this. And when we come back, we're going to create a photo album, and that would be our graduation present for the two of them. and how they spent their last summer with their parents. And so everywhere I went, I was taking pictures. And of course, we're going through Europe and we're visiting all these great places. But when we're visiting all these great places, it's during daylight. And when you're outside during daylight, the dynamic range of your phone, which has become my most important camera, simply isn't enough to be able to deal with it. And what was frustrating to me, and I kept sending emails back to the engineers, that gosh, we got to make HDR faster, we got to make HDR faster, we got to make HDR so fast that I can always use it as my camera. And the reason for that is because in life, you only get one shot. You only get one shot. There are so many experiences where we only get one shot. And because our camera is now our phone is now our most important camera, the ability to capture that magical moment comes and goes. HDR today, our cameras today, really needs to be improved. And let me illustrate that. So this is V, this is one of our employees, and she's standing in front of a tinted window, just to make it even possible to take a picture of her standing against a bright sunlight. She's standing against a tinted window, and obviously you look, she's perfect, she looks beautiful, and she's well taken. It's a nice camera. This is the iPhone 5. However, you can't really tell what the outside is. It's washed out. It's washed out because the dynamic range of our camera, the iPhone 5, doesn't allow us to both capture her fidelity in the dark and the bloom outside, the extremely high, the bright sunlight outside. And so you can solve this problem by focusing on the outside. And this is what you get. Now you realize that you're in Las Vegas, but unfortunately, B has disappeared. And thankfully, there's a great new technology. This great new technology is called HDR. HDR works in most of the superphones today. They all have some kind of capabilities around HDR. And with an HDR shot, this is what you get. Quite frankly, it's a nice camera. It's a nice photograph. It's a nice photograph. She's very beautiful. She's standing in front of the palms, and everybody knows that she is enjoying a trip in Vegas. Now she goes outside, and she's standing out in the middle of the sun, and as you can see, all of a sudden, everybody behind her is washed out. Still a very nice picture. The sky's gone, the building's gone, and apparently some alien is walking just behind her. And so her boyfriend says, well, I have the technology for that. I have the technology for that. That technology, I'm a photo enthusiast. I know my stuff. I understand high dynamic range. I'm going to turn on HDR. Well, this is what you get on an iPhone 5. Well, the reason for that, now you see the background, because the camera took 2 shots, and because there's movement in the back, it's very difficult for the camera, the image processing technology software, to now realign and figure out what's the best way to put the picture back together. Today's camera works like this. It's a sensor, goes into an image signal processor, which takes what is called the Bayer patterns and turns it into RGB. In the process, it enhances the image quality, extracts the lumens, extracts the chroma, and reconstructs what it looks like to you, a JPEG image. That JPEG image is stored into system memory, after which the CPU can come back and do some wonderful magic with it, such as HDR. What Nvidia's Tegra 4 architecture does is something radically different. Something radically different. We introduced a brand new way of designing our chip so that we could put our processors closer to the imaging pipeline. The first thing that you see, and let me just go back, this is old, this is new. The first thing that you notice is that we take 2 shots at once. We take 2 shots at once. 1 shot with high exposure, 1 shot with light exposure. Then the first thing that we do is we dump it into this computational photography engine sitting in system memory. And once we do that, this engine could now take advantage of all of the processors on chip That's why we have 72 cores. That's why we have 4 A15s. That's why we have this powerful ISP. And with this computational photography engine, we could do the necessary mathematics so quickly that effectively at the end of the shot, you have HDR. Let me illustrate. If you look at it today, there's me standing in front of the palm, takes the first picture, goes through the sensor, goes through the ISP, goes into memory. Changes the exposure, that's what the HDR software does, changes the exposure, goes through the sensor, goes through the image ISP, goes into memory. Then the CPU fetches both of those images back out of system memory and does registration, does necessary warping, basically is taking two images, trying to align them pixel by pixel. Obviously very, very hard with your hands shaking if the subjects are moving. But nonetheless, it does its best possible job to register, to align, to warp everything so that it fits nicely together. And then it has to take this very, very large dynamic range effective photograph and re-tone map it down into something that can fit within one photograph's dynamic range. Okay? All of that mathematics takes time. In the case of the iPhone 5, it takes about 2 seconds. It takes about 2 seconds. And that's why if you're standing perfectly still, you take a great photo. If you're moving around, it's a problem. 2 seconds is a very long time. Well, the way that Tegra 4 does it is we go bam, bam. We take 2 shots. 2 simultaneous shots. And then all processors are deployed and running to do the alignment, the warping, the registration, the tone mapping, all of the necessary image processing, and boom, goes out one single photo. It basically is a one-shot HDR. As a result, whatever photograph you could take with a one-shot camera with one exposure, you could now take in HDR. Whatever you could take with one exposure, you can now take in HDR. And if you think about this architecture, imagine what else you could do with that. But before we do that, let's demonstrate. Let's demonstrate what Tegra 4's magic camera can do. Okay. Well, I understand that we're in Vegas, but we decided to go to Tahiti. And I'm taking a vacation in Tahiti, and I've invited a gamer. I met a gamer at Tahiti, and I noticed that we have a lot in common. And her name is Holly. And Holly, I understand that you like to play video games. What are your favorite video games?
Skyrim, I like everything Star Wars, and Red Dead Redemption, anything RPG.
Like all the gamers on the audience are going, wow, gamers, they don't look like that. Well, anyways, Holly and I turned out, we hit it off, we have a lot in common, and so why don't we invite someone to take some pictures of us? Okay, so Brian is the chief architect of our computational camera. Brian Cabral, sir.
How you doing, Jensen?
Great to see you. I understand that you have a camera you like to. Now this is a prototype camera. It's a prototype tablet, and you would like to take some pictures of us.
Yes, I sure will.
Hang on a second. I want this one to look good.
Take it off, Jensen. There you go.
Yeah. Make sure I'm standing here.
Yeah.
Good. Right here.
Yeah. We can see it's all washed out. And let's just check out what we can do with some live HDR here. That's a lot of light being thrown out behind the.
Let me see if I understand what you're doing. I can barely see it through the reflection of that glass. But you're basically running HDR in live video right now.
All that computation that Jensen was talking
Wow,
about.
that's really amazing. So you're running in live video, and you're doing HDR on, let's see, on the right side right side of the audience?
Left side.
Your left side.
My left side.
Yeah. I'm talking their left side.
So let's take a picture.
Okay? So real. All right, I want to try to look good. Come here, Holly. Hang on a second. Come here.
Let's get you all set up here. Are you good then?
All right, let's check it out. Thank you. Let's check that out. Let's Holly turned out good.
Let's check it out. Zoom in. Yeah, there you go. Could you focus it? Yeah, there you go.
Wow.
That's a keeper for your vacation.
Wow. Okay, so let's see what happened here. Basically, without HDR, the background is completely blown out. But with or we could focus in on us, or we could focus in on the background. But otherwise, we would be underexposed. With this one-shot HDR, Brian was able to keep HDR running all the time, and he could do it while video's running, and he could take a single shot. And gosh, every shot from now on is going to be beautiful, and we can keep our memories forever.
Yeah, it's instant. It's always on. Far less than a second.
That's fantastic. Thank you.
Thank you.
Congratulations.
Thank you.
Okay. So, Tegra 4, this new computational engine. There's so much you could do with this architecture. You saw the one-shot HDR today. You saw the HDR video. There's also HDR preview. It doesn't record it, munch on it for a while. It's recording, it's preview HDR. But one of the things that is really fantastic, you probably didn't pick it up. Because we're doing everything at the software and hardware layer inside our chip, what comes out of the chip, right off the bat, is HDR. What that means is, every software application today just works. No modification necessary. No porting necessary. You could either decide, I would like to have HDR on all the time, and then as a result, in that particular case, it was just a Google camera that came off of Android, pure Android, and it is fully HDR. The other thing that we didn't have to do just now, and I don't know if you did, was to turn on the flash. When you take two shots, how do you know when to flash? In the particular case that we took one shot, and then the flash works again. So you can use the flash in dark environments, turn on HDR all the time, works with every single application. The future of computational photography is quite exciting. This architecture is the first implementation for us, but you could just imagine Tegra N, Tegra N+1, Tegra N+2 will continue to innovate around this area. Some of the things that I'm excited about in the area of computational photography is really to turn your camera into a device that can take pictures far beyond what DSLRs could do. Just as digital music players made it possible for you to enjoy music, not just in a digital way, but in a way that you couldn't enjoy with CDs, cameras will do the same thing. These cameras, with these supercomputers, if you will, behind them, will do amazing things. HDR panorama will be possible. Wouldn't it be great when my kids were taking their karate black belt tests and they were doing their final performance? I would have loved to take a stroke motion of them. When they jumped up in the air and did a triple somersault, it would be fantastic to see their flipping kicks and capture it in a stroke motion example. The high dynamic range is a picture that Spencer took this summer, and of course we could also do 3D reconstructions. You take multiple shots of an environment, reconstructs the 3D space, and as a result you can look around. One of my favorites, the ability to continue tracking an object so that it stays in focus. Really, really hard to do that with a camera today. So if you're following your kids as they're playing soccer, the odds of being able to use a camera, a digital camera, to capture an action shot, impossible. But now, with computational photography, we could create technology that makes it possible for us to capture those magical moments. Computational photography, a brand new area that Tegra 4 is going to be able to take us into. I'm super excited about it. Video games.
Yeah.
You know, you can't come to a Nvidia event without talking about video games. Video games. Tegra really started this whole movement around really, really rich games, even for mobile devices. We created a store called Tegra Zone, which allows us to curate great games and make them available in an organized way and present it to gamers all over. Every single game has been optimized, every single game has been tested rigorously so that when you download it, it just works. Whether it's Tegra 3 or Tegra 4 or Tegra 2, it just works. Our engineers have worked with the developers to take full advantage of the platform, and our engineers have worked with the developers to fully test it across all of the various devices that we're shipping. We go through great pains so that we could help gamers enjoy the games at its full capability, and also to help the game developers realize their imagination is the best possible way. Tegra Zone has been downloaded 6 million times. 6 million times. We're just so proud of it. And to Tegra Zone is to Tegra what GFE is to Geforce. That's one way to think about it. And so with that, let me introduce a new game that we've never seen before. And take it away, please. Dead Trigger 2, thank you very much for that. We're going to save a few. Give me a moment, okay? Give me a moment. I'm going to save a few for you. But let me finish Tegra 4. There's something that happened about 18 months ago. We met a company that was working on this really, really cool technology. And it really connected with us because we were, you know that we've been in the computer graphics industry for 20 years. Our company has, and many of us have worked on computer graphics much longer than that. And we came up through the world of accelerators. A chip was dedicated to one function. It's got all these acceleration techniques necessary to perform the functionality of a very rigorous pipeline of things that you have to do to ultimately turn a three-dimensional graphics command into pixels on a screen. The OpenGL pipeline was very well documented, it was very rigorous. We built accelerators to stream out and pump out these beautiful pixels from 3D commands. Over the years, we realized that in order for us to take computer graphics further, we had to make the GPU programmable. And the reason for that is because the artists, the game developers, can't be constrained to a singular way of doing something. They need a nearly infinite palette to express their artistic imaginations. And so we created this idea called the GPU. The programmable shader was invented. And we've seen the revolution that happened when we were able to move from a fixed function accelerator model to a programmable model. The revolution was really, really clear. But that programmable shader wasn't just a normal microprocessor. It had to be invented in such a way that achieved the performance of a fixed function pipeline, but the programmability and the flexibility of a processor. And it took us several generations really to make that successful. 18 months ago, we're getting involved in the wireless industry. And we met this company that had seen the same things that we saw in our industry and made a bold move to jump from accelerator fixed function approaches to modem technology to a programmable approach to modem technology. Now this technology is called software-defined radio, SDR, and it's been talked about for decades, frankly. However, it has never been achieved successfully. When we met this company 18 months ago, they were the world's first commercially shipping SDR modem, and they were shipping in 3G. They were shipping in 3G. We got so excited about their approach. We got so excited about their team. And we decided to buy this company called Icera. Icera, 18 months ago, became Nvidia. And starting this month, we are going to be sampling our first modem. It's called the i500. The i500 is an elegant processor. It has 8 modem processors in it. These processors are programmable, and they run the entire modem stack. 3G stack, 4G stack, the Viterbi decoder, the turbo decoders, all the interference algorithms. It runs all of the software necessary to deliver the modem, and it does it in a programmable way. There are 8 processors inside, each of them 160 gigaops, and 8 of them together delivers over 1.2 trillion operations per second. 1.2 trillion operations per second. Now just to put that in perspective, this little tiny chip is a modem, remember? This little tiny chip is doing 1.2 sustained trillion operations per second. That's 200 trillion. This little chip is 1.2. Now, of course, the mathematics that it does is very specific to wireless communications. But nonetheless, it's a programmable processor. 1.2 trillion operations per second. If we had to use a general purpose microprocessor to do that, my guess is that our estimate, your fastest, highest performance 6-core Core i7 running a couple of 100 watts couldn't even do it. So we were so excited about this technology, and this month we are sampling the i500 modem part of Tegra 4. Just incredibly excited about that. Now, just to illustrate the benefits of a software-defined radio, or this software modem technology, compare it to the state-of-the-art LTE modem. It is so much smaller, and the reason for that is this programmable architecture was designed for modem technology, and because it's able to reuse each one of the processors for every stage of the pipeline, it doesn't have to replicate these fixed function blocks. Frankly, if Nvidia today, if our industry in graphics was still using fixed function processors, in order for us to deliver the type of visual quality that we're seeing today, the chips would be many times larger as well. We were so enamored with this technology, we took the chance, and I am incredibly proud and gratified to say that we are now sampling a 4G modem based on this very technology. Let's give those guys a round of applause. Now, the benefits of this modem being small is one thing. However, don't forget, because it's a software modem, it could achieve things that a fixed function modem cannot. As you know, the world is not all the same, and every single city, every single area we're in has different capabilities for connectivity. When you're in New York City, you're trying to figure out how to reconstruct all of the beams, cellular beams, into a signal that one phone can handle. On the other hand, if you're in the Great Plains of America, you're so far away from a cell tower, you're not trying to do beam forming. There's only one beam. It's coming from about 50 miles away. you're trying to figure out how to extract this little tiny possible signal from the background noise that's always there. And so these different environments requires different types of algorithms for optimization. The benefit of this SDR, just as the benefit of GPUs, there are different things you can do that aren't possible if it was fixed function. SDR allows us to download into the processors algorithms that are optimized for different areas of interference. And we could also improve it over time. And just like software downloaded on your phone, we could use over-the-air updates to upgrade your phone. So software-defined radio to software modem technology, really, really exciting. And so that's Tegra 4. That's Tegra 4. 72 GPU cores, the world's first quad-core A15, the energy sipping core, the 4+1 architecture, still has the prism technology that adjusts the backlight dynamically on every single frame in hardware to conserve energy. And then also, finally, also our first 4G LTE modem, Tegra 4. Well, I've got a little bit of time left, and I'd like to talk to you about something new. Something I hope you're surprised by. If you're not surprised, I'm going to be surprised. Something new. You know, gamers today play games on every platform. They play games on consoles, they play games on PCs, they play games on phones, they play games on tablets. Next generation gamers play literally everywhere they can, whenever they can. Just like we enjoy movies on multiple screens, just like we listen to music on multiple devices. There are two ecosystems that are growing incredibly fast. The Windows ecosystem, the Windows gaming platform, because of all the things that we talked about, the incredible pace of technology, the rich graphics that the technology affords, the open platform, and therefore the innovative new business models like free-to-play. And because the gamers themselves are on a platform where they can make contributions to the gaming experience, they are innovating too. The other platform, Android, the fastest operating system growth in the history of mankind. Hundreds of millions of people have Android devices. There are millions and millions of Android gamers, and the games are getting better than ever. Our feeling is that the PC games and the Android games will continue to flourish. But there's a way for us to help these gamers enjoy games even better. And that as a company, we are really the only company in the world who has the processor technology, the system software technology, and the dedication to these two platforms and the gamers within it to go build devices that can allow us to enjoy games in a very different way. In a very, very different way. And so our engineers are gamers too. And so we asked ourselves, what if? What if we could build such a device? And so we started playing with it. And today I'd like to share it with you. Ladies and gentlemen, please enjoy this video. I'll take your money shortly. Ladies and gentlemen, I'd like to introduce you to Project Thor. Excuse me, Project Shield. It's nothing. You know, I have to live in code words the vast majority of my life, and only for one singular moment, I have to learn not to use the code words. Please accept my apologies. Hey, Kunrad, let's flip through this real quickly. Unfortunately, I'm taking too long doing this. Let's go through it quickly. Let's show them what Shield is all about. Of course, Shield is going to be the world's first Tegra 4 processor. Next. Packed with batteries, 38 watt hours, gives you somewhere between 5 to 10 hours of gameplay. You don't have to use up all your battery life on your phone anymore to play your games. All of the games just show up, obviously, because it's in the Android Play Store. It's in Tegra Zone, and it's in the cloud, and so every game that you own magically shows up, and now you can enjoy it for 5 to 10 hours. And if you're just watching high-definition video, about 24 hours. 24 hours of high-definition video. Next. One of the most amazing part of Shield is the sound system. You can't enjoy games, as you know, without great sound. This is the first mobile device that I know that uses a bass reflex system. Basically what it does, there's a tube that connects to the driver, the output of the driver, and it takes advantage of a large space of air, and the elasticity of the air, to extend the low end frequency range of these devices. But it works very similar to essentially blowing air over the top of a bottle. And the sound resonates inside the bottle, and it sounds bigger than obviously the air that you blew across. This particular system is twice the signal-to-noise ratio and the frequency response of an HP laptop with Beats audio. We have a signal-to-noise ratio of 79 compared to an iPhone 5 of 66, on par with these dedicated jam boxes. Okay, so this is the world's first custom-based reflex system. It even knows when you set it down. It changes the audio processing so that the audio effects are different. Next, please. Gamers need great game controllers. Buttons, analog joysticks, digital D-pads, bumpers. Hey, Kunrad, let's rotate this around. Oh, what? This is a video you could rotate. Look at that. Turns out it's not a video at all. Yeah, okay. Well, that's something you would expect NVIDIA to be able to do. All of this is rendered using the latest UE4 engine, and the rendering is beautiful, as you can see. Bumpers, triggers, a world-class game controller. Next. This device is pure Android. Pure Android. We didn't put a skin on top of it. We didn't change it. It's pure Android for Tegra 4. And the only thing that you have to do is hit the shield button right in the middle. It hyperspaces you into the shield mode. You hit it, it drops you back into Android. Pure Android. Everything works exactly as if you would expect an Android device to work. Next, please. standard IOs. No proprietary interfaces, proprietary jacks. You don't have to buy yet another charger. All of your USB chargers just works. It's an open platform, and so you could add more memory if you like. So there's a micro SD slot. Next, please. And then lastly, a customizable tag. We expect you to have, well, we're hoping that you have several in every household. And so if you have several in every household, one in your living room, one in your family room, one in every bedroom, you're going to need to know whose is whose. And so this tag, this little shield, if you will, comes right off, and you can replace it with one. Oh, look at that. Something that you can customize. Okay. Ladies and gentlemen, Shield. You were probably starting to wonder whether it was just a 3D animation. This is Shield. This is the work of love of many engineers at Nvidia, and now we're going to show you what it can do. Okay, so before, while Jason is getting set up, just to give you a sense for the size of Shield, we want a Shield to, number one, be a perfect controller. Its job is to help you enjoy games. And although touch is fabulous for swipes and pitch and zooms, and for gaming, it's really quite challenging to play with touch. And we think that for most rich games, you still want the best possible controller, and that's the place to start. The second objective for Shield is to make it as small as possible. There are so many people now who are carrying these controllers in their bags and connecting it up to their phone so that they can play their games. And so now this device, the Shield, is essentially the same size as any controller, and so there's no reason to carry it under control. All of your applications, all of your content, all of your games just show up. And so let me demonstrate it to you. This over here. Okay. And so because you guys fight me for Wi-Fi, I'm going to have to use a hardwired Ethernet and an HDMI. Now, let's see, you could change the camera. Okay, you guys change it. Are you change the camera? Okay. Okay, so first of all, I'm connected to a LG 4K television. Okay, so this is a 4K television. And over HDMI. And first of all, this is just Android. You can enjoy music. You get home, goes back to home. Touch works just fine. You can control it with the controller or touch, whichever you like.
Spirit of Maryland calling me, orderly, bullish.
Exactly what you would expect Android to do. Okay. Let's see. Movies work. can travel with me wherever I want to go. And with a connection to the television, every place is really just about everything I own. Let's see. Well, Facebook works. That's pretty good. They surprised me with that. Okay. Let's see here. Let's find something to try. You know what? Why don't we do something that's the first time ever? This is the first time you are going to see a 4K video coming off of a mobile device.
Yeah! Do not misunderstand me. Danger is very real. But fear is a choice. Do you know where we are?
No, sir.
Wow.
This is Earth.
4K video looks pretty darn good. And so first of all, this is an Android device. It's pure Android. However, by simply touching the shield button, now you're inside a game environment. These are the games that are loaded on here. Tegra Zone game stores right up there. Let's see. Let's find one that everything's 100% Android, and these games are all available on Tegra Zone and optimized for the controller. And I'm, as you see right now, driving a 4K display right out of Shield. Time to try something else, and so let's try one more game, and then
Spectators can't wait for the final battle. Tonight, two magnificent fighters will collide.
two magnificent fighters. All right, I think they're talking about me. All right. Oh.
What a shot to the head. Devastating combo. Great uppercut.
Oh, a little uppercut there. Look at that.
Oh, look at that.
Pretty fantastic graphics. All right, let's try something else.
Tricky combination.
All right, how's that? Pretty amazing.
Talk about.
Okay, all right, that's enough of that. Oh, okay, all right, that's enough of that. Okay, so I think that's pretty fantastic. This particular device is connected to the Tegra Zone. It's optimized for playing games, has a great audio system, but really, what else can it do? Well, One thing that we would expect a device like this to be able to do is multiplayer games. I mean, it's connected to the network. We should be able to enjoy multiplayer games. And to help me do that, let me invite a couple of my friends up here. Jason and Kane. All right, Jason. Hey, Jason. All right, you sit down. You do this. This is the CEO of the game company that created hockey. Let's see what Shield can do. Just get it loaded up here. Unreal Engine just runs. Yes. Mech Combat FPS. Wow. Okay. Is the graphics amazing? Yeah! These guys did a great job. Nice job. That's really amazing. All right, you guys. You can keep All right. Thank you very much. I appreciate that. Congratulations. All right. So you have what we're looking at is a gaming portable playing Android games multiplayer. It's connected in a multiplayer environment. It's connected to television, and that's really a great way to play Android games. It's Android the way it's meant to be played, and I think that's fantastic. I caught that. You caught that. But it seems that all of this technology, if we're to reimagine how we utilize the technology that we talked about today, and extend the gameplay for even PC players. One of the things that PC players have wanted to do for quite some time is to be able to enjoy their games on television. Now, the thing that makes perfect sense is that the PC has become so powerful. It is really the world's most powerful game controller. And yet, because it's not sitting next to a television usually, and because it doesn't have a user interface that's designed for television play, it's been difficult to put the PC experience in front of a television. Well, finally, we're about to change all that. Valve and the guys at Valve have done a great job with this new user interface called Big Picture. Big Picture is connected to all of the games on Steam. There's some 54 million active users on Steam, almost 2,000 games. 70% of the digital distribution of PC software, PC games around the world comes through.
Someone wanted to chat.
Oh, is that right? Somebody wants to chat? Well, that's one of the beautiful things about this device. Because it is a pure Android device, everything that all of your accounts, everything that you do with your Android device just works here. That's really one of the beautiful things about it. And so Big Picture extends their user interface from a PC to television format. However, how do you get your PC to sit next to the television? In my house, the PC is far away. And so the question is, how do we do that? Well, today we'd like to show you something that is possible as a result of all the technology that you guys saw today.
I'm making a
It's
lot
you
of
guys
friends here.
out there giving us a bad time. All right. You're messing with us now. Okay, so why don't we suppose we could stream from PCs. You want to try that? Yeah. So Jason, why don't we do that? Okay, so the third tab on the Shield zone, you have games, which are all the Android games that you've purchased. You have Tegra Zone, which is the store that you can buy new games from. And then there's PC. PC is connected to your home PC. Whatever PC that you have with a Geforce GTX inside, you would connect like this. And ladies and gentlemen, thank you for coming tonight. You would stop texting us.
Here's the text.
You're killing me. You're killing me. All right, so we could do it.
I think
Theoretically, it should work.
Theoretically, it should work.
Between the grid technology and Shield and all of the hard work that if I keep talking, would it help?
I don't know, Jason. I don't know if talking is going to help.
Oh no! I'll show you more Maxim. One more time.
Give it one more go.
You want to do it one more time? It just doesn't want to do it.
PC just doesn't want to pop up here for us.
There we go. Not what you want to see, though. That's not what we expected.
Put it on.
So, anybody back there that could we pretend like it was connected? How would you pretend like it's connected? This is where you go. This is where you go. Vicky, help! They're just friends. They just want to see a miracle. I want to see a miracle. You want Shield? You still do?
Yeah,
Okay, I want you to pretend now.
I have faith.
Yeah, you do. We'll get it working. We're going to try it again?
I think we need a little bit more time.
You need a little bit more time? All right, so tell you what, I am going to say a few more words, and then you take your time, okay? But fast. Now, so this is the culmination of 5 years of work across every single organization. Across every single organization. That's right there, ladies and gentlemen. Let me sit back down. And just in time, we got 44 emails. Stop sending us emails. You're killing us. Okay, so let's, how about most wanted real quick?
Yeah, let's play some Need for Speed Most Wanted.
Okay, now, look, this is a GeForce GTX 680 sitting in this PC right here. We just made a connection. There's a piece of software in GFE that is now taking what is rendered by GeForce and streaming it to Shield. And it's going to be good?
It's going to be good.
Now you should be, you're sitting anywhere in the house. Your PC is in your room, and you're there sitting on the couch pretending like you're spending time with your family. You know, you're in bed pretending to be sleeping. Or you're in some other room where you always have your mobile device. Now spin that car around. I love this car. This is graphics that Jason is currently enjoying on Shield. That's fantastic. You can't do that. So what's happening here is that Shield, the controller commands are being sent to the PC. The PC with GeForce GTX inside renders the screen, computes the next scene, and streams it back out over Ethernet in this particular case. But at home, it'd just be over Wi-Fi. There's plenty of bit rate for that. In just a jiffy, the latency is so short. It's as if you are right there connected to the PC. You can enjoy it on your display here, or you can enjoy it connected to television. Now, show me Steam. Can you show me Steam?
I can. Let's take a look.
Show me how I'm going to. Oh, nice.
So let's take a look at Assassin's Creed first, and then we'll go to Steam. Okay. That?
Assassin's Creed. The latest Assassin's Creed. Now, what's Assassin's Creed about, anyways?
So Assassin's Creed is an action adventure. You are a
Time travel.
You're a time traveler. Well, right? You time travel in an interesting way. You're from a long lineage of assassins, and you travel through their memories. There's a machine called the Animus that you can relive their memories through. And Assassin's Creed 3, you go back and visit one of your ancestors during the Revolutionary War, and are trying to collect some knowledge and information to be able to avoid a global disaster.
Wow. Okay. Well, who likes global disasters?
So we're going to be Desmond here.
That's amazingly beautiful. Hey guys, what do you think about this graphics?
What are you saying? Your commissions with Edward Brown, Sir.
But he's yet to reach
They arrived in Boston here after they traveled from England. And one of the cool things about this game is the free running. So you can climb up on,
Please! Someone stop it!
sort of run all over the place.
The frame rate is fantastic. The interactivity looks perfect.
You can get some really
The
beautiful
best
things.
possible graphics you can put on television today. This is running on a 4K television. Wow, that's good. Okay. That's great. And if we ignored all that other stuff, just now? It just worked. It just worked. Wow, okay, all right.
And then of course,
So of course, Steam, I mean, boy, the #1 most important digital game store in the world for games. Look at that. Store. Everything just works, just like those two other games. Right on. Thank you, Jason. Good job. I guess if you press things enough times, it works. And so you saw Shield enjoy games from two of the most important digital stores in the world. The Google App Store, Play Store, within it, a curated game store called Tegra Zone. Everything you buy there, on your phone, on your tablet, from your PC, using their website, just shows up on Shield. You download it, and you play it the way it's meant to be played. You can also connect to the other great store, Steam, with almost 2,000 games, with 54 million gamers. All of these gamers are now able to enjoy their Steam games from anywhere around the house. And hopefully in the future, even beyond that. And our vision is that the way you play games with these devices, because you have a screen here now, and the controller and the computer, the processors are right there inside the controller, the type of games we'll be able to enable will be very different. Imagine each one of your Shields, you see the driver's cockpit view. However, everybody who's inside, they're watching you, aren't looking at the cockpit view or a split screen view, but they're looking at a spectator view. You can imagine all kinds of different ways now to create games as a result of this kind of model. And so, just to summarize what we talked about today, the consumer electronics industry has been radically changed over the last 10 years. The PCs connect to mobile devices, and these digital devices have cloud services that provides for music and movies and books. And all of these devices can stream to multiple devices now and multiple screens. We wanted to, over the last 5 years, create the pieces necessary for us to do the same for video games. And so today, to summarize the things that you've seen today, this is what we've done. We created GFE, which is essentially an application that allows the end user to enjoy the game simply, but to take advantage of their full potential of their personal computer. It makes video games simple like a game console on a PC. There's a piece of software that's inside this GFE that also streams and connects it to a mobile device. This mobile device is called Shield. Now you can enjoy your PC games processed on GeForce GTX, streamed to your device anywhere in the house. This Shield also allows you to, today, connect what we showed you with HDMI, but in a very short period of time, we'll also be able to connect wirelessly, just like AirPlay, using the same technology that we showed you today using streaming technology, to stream it to your television as well. And so you should be able to sit on your couch, and if you decide that you would like to share the movie that you're watching on your Shield on television, you simply have to beam it to your television. The television needs a receiver. It could be a smart television. It could be a Ouya game console that they're working on. It could be a little dongle that is Wi-Fi to HDMI. All of these experiences are then supplemented with a cloud service made possible by Grid. Cloud services will come to us in a lot of different channels and a lot of different formats, just as cloud services today and TV shows and otherwise. And together, it creates the ability for us to enjoy video games on any device, at any time, at any place, and on any screen. These elements of technology has taken us quite a while to put together, and it looks like we have a little bit more work on Shield. And, but I think it's going to usher in the same type of experiences that we were able to enjoy for music and movies over the cloud in this untethered way, but now finally for video games. I want to thank all of you for coming today. Hope you stay around and enjoy the party with us. Thank you, everybody.